this lecture, we will be talking about entity relationship modeling. After completing this chapter, you will be able to identify the main characteristics of entity relationship components, describe how relationships between entities are defined, refined, and incorporated into the database design process, see how ERD components affect database design and implementation, and understand that real-world database design often requires the reconciliation of conflicting goals. The entity relationship model forms the basis of an entity relationship diagram. This is the conceptual database as viewed by the end user. The database's main components are the following. We have the entities, attributes, and the relationships. Entities are the object of interest to the end user. This refers to the entity set and not to a single entity occurrence. The entity relationship model corresponds to a table, not to a row, in the relational environment. The ERM refers to a table row as an entity instance or entity occurrence. In Chen, Crowsfoot, and UML notations, an entity is represented by a rectangle that contains the entity's name. The entity name, which is a noun, is usually written in all capital letters. Attributes are the characteristics of entities. In other words, these are the things that we would like to know or collect for our entities. An attribute can be required when you want it to have a value and cannot be left empty. An attribute is said to be optional if you do not require it to have a value and it can be left empty. The domain is the set of possible values for a given attribute. An identifier is where one or more attributes that uniquely identify each entity instance. The composite identifier, which is the term we are using to refer to the primary key composed of more than one attribute. We also have composite attribute, which refers to the attribute that can be subdivided to yield additional attributes. We also have simple attribute, wherein the attribute cannot be subdivided. Single-valued attribute is an attribute that has only a single value, whereas multi-valued attributes are attributes that have many values. Let's talk about the attributes of the student entity as an example. In Chen model, the attributes are encircled and are connected to our entity, which is the student. If you're going to make use of the Crowsfoot model, the name of the entity would be above, and inside the dedicated space are the lists of your attributes. You will notice that there are some attributes that are in bold. That means that those attributes are your primary key. If you have attributes that are multi-valued, you can see in the Chen model that you have two lines to indicate that it is multi-valued, which is none in the Crowsfoot model. But in the Crowsfoot model, if something is a primary key, you can specify it as PK. In the Chen model, if something is a primary key, you can just underline the name of that attribute. Now, if we have multi-valued attributes, we can do one of these two things. We can either create several new attributes, one for each component of the original multi-valued attribute, or develop a new entity composed of the original multi-valued attributes components. Next is the derived attribute. Derived attribute is an attribute whose value is calculated from other attributes. And from the name itself, it is derived using an algorithm. If we recall from our previous example, the car color is a multi-valued attribute because, well, it has multiple values. It can have a color for the top, for the body, among others. So to address the multi-valued attribute, we can do either of these things. We can create separate attributes referring to each of the colors, just like what you can see in the first one. Or we can create a separate entity, just like on the second one, wherein we are specifying the color and the section to which we are talking about. Is it either the top color or the theme color or the body color? Now, if we have a derived attribute in the Chen model, we depict it by using a broken line. So in this case, you would know that employee age is a derived attribute. And it makes sense because if you have the date of birth, you can just derive the value of the employee age. How do we know if we need to store a derived attribute or not? There are certain advantages and disadvantages for storing a derived attribute. For the advantages of storing it, it saves CPU processing cycles, it saves data access time, the data value is readily available, and can be used to keep track of historical data. For the disadvantage, of course, it's going to require constant maintenance for you to ensure that the derived value is current, especially if any changes used in the calculation has changed. For the advantage of not storing the derived attribute, well, we are going to save storage space because we are not storing the derived attribute. Also, the computation can always give us the current value. The disadvantage of not storing is it uses CPU processing cycles because you need to compute every time you would need the derived attribute. It increases the data access time as well, and it adds coding complexity to your queries. Now let's talk about relationships, connectivity, and cardinality. The relationships are the association between the entities and they operate in both directions, as we have said in our discussion in the data models. The participants are the entities that participate in the relationship. The connectivity is the one describing the relationship classification. It can either be one-to-one, one-to-many, or many-to-many. Whereas the cardinality is expressing the minimum and maximum number of entity occurrences associated with one occurrence of related entity. In the ERD, cardinality is indicated by placing the appropriate numbers beside the entities using the format x, y, where x is your lower limit and y is your upper limit. To identify if something is cardinality or not, you can ask the question, for each instance of entity A, how many instances of entity B is associated with the one instance of entity A? Now let us talk about existence dependence. In existence dependence, entity exists in the database only when it is associated with another related entity occurrence. Whereas we have existence independence if the entity exists apart from all of its related entities, and referred to as a strong entity or regular entity. Next is relationship strength. We have either weak non-identifying relationship or strong identifying relationships. In a weak non-identifying relationship, the primary key of the related entity does not contain a primary key component of the parent entity. Whereas we have a strong identifying relationship if the primary key of the related entity contains a primary key component of the parent entity. The following are the conditions of a weak entity. First, it is existence dependent. Second, it has a primary key that is partially or totally derived from the parent entity in the relationship. In other words, you have a foreign key in the entity that is also a primary key. Now, let's take a look at some examples of weak entities in an entity relationship diagram. In the Chen model, weak entities are specified by having two lines in your entity. By the way, the weak entity over here should be dependent. Whereas in the Crowfoot model, the weak entity are identified by taking a look at the line connecting the two entities that you have. If it is a solid line, then you have a weak entity. So in this case, you can also see that from the employee table to the dependent table, we have an existing primary key in the dependent table that is a foreign key as well from the employee table, or a primary key in the employee table, which is the employee number. And if we're going to take a look at the table themselves, this is how it might look like. Now let us talk about optional participation. Optional participation is such where one entity occurrence does not require a corresponding entity occurrence in a particular relationship. Let's take a look at this example. We know that class is optional to courses, meaning if you have a course, like let's say IT 131-8, you can generate classes per term, like the section that you might have right now. But there are some semesters or terms where IT 131-8 is not offered. So, meaning, in a certain semester, classes are not really required, but is optional to have classes to a certain course. That is why, to specify this relationship, this level of participation, we do that by putting 0 or a circle in our closed notation. So in this case, from the course going to the class, you can see that this is 0 to n. It is possible that the class is 0, meaning it is optional. On the other hand, in mandatory participation, one entity occurrence requires a corresponding entity occurrence in a particular relationship, meaning the relationship is mandatory. If in your business rules, the course and class, they are mandatory, meaning if you have a course, you need to create classes for those courses, then this is how we might be doing it. So in the closed rotation, instead of using a circle, you can use a line to specify that, okay, this one is mandatory and should have at least one occurrence.